Welcome to Coaching Peeps. I go by the name Peeps, and in today's class, we're going to talk about acid-base chemistry. Okay, let's start with what an acid is. According to Arrhenius theory, an acid is a substance that dissociates completely in water to yield hydrogen ions only. An acid also is a proton donor, according to Bronsted-Lowry's theory. Also, Lewis defined an acid as an electron pair acceptor, that is to say, acids accept electrons. Examples of acids include hydrochloric acid, that's HCl, tetraoxosulfate 6 acid, that is H2SO4, also known as sulfuric acid. We have water, H2O, ammonium ion, NH4 plus. Please note that the plus goes up. Hydronium ion, H3O plus, the plus 2 also goes up. Then hydrogen sulfate ion, HSO4 minus, the minus 2 goes up. Moving on to the physical properties of an acid. Dilute acids have a sour taste. The pH of an acid is less than 7, that is to say, they are acidic. Also, the term blue litmus paper are red. Moving on to the chemical properties of acid. Acid reacts with bases to form salt and water. The question below is hydrochloric acid plus sodium hydroxide will give you sodium chloride and water. Another chemical property is that they react with metals to give salt and hydrogen. The equation below is tetraoxosulfate 6 plus magnesium will give you magnesium sulfate and hydrogen. Moving on to the definition of a base. According to Arrhenius, he defined a base as a substance that dissociates partially to form hydroxide ions only. Also, Bronsted-Lowry theory of a base states that a base is a proton donor. Lewis also defined a base as an electron pair donor, that is to say, bases accept electrons. Moving on to examples of bases, we have water. Water can be an acid, water can be a base. Remember, the pH of water is 7. We also have hydroxide ion, that is OH minus. Remember, the minus is up. We have ammonia, which is NH3, and we have chloride ion, which is Cl minus. There are other examples of bases, like hydrogen sulfate ion, that is HSO4 minus. Remember, the minus is up. Sulfide ion, S minus. Remember, the minus is up. Okay, moving on to the physical properties of bases. Dilute bases are bitter. They have a bitter taste. Bases are soapy to touch. Bases have a pH of above 7, and also they turn red litmus paper blue. Another important physical property is that concentrated bases are corrosive. Okay, moving on to chemical properties of bases. We have reaction with acids to form salt and water. The equation is given below. We have calcium oxide plus 2 molecules of hydrochloric acid will give you calcium chloride plus water. Okay, note that the pH value of a base is greater than 7, that is to say that it's alkaline. Here are some key points you should know. A conjugated acid of the base occurs when a base accepts a proton. A conjugated base of the acid occurs when the acid donates a proton. Take a look at this equation below. From the equation below, HCl is the acid, Cl is the conjugate base of the acid, NH3 is the base, and NH4 is the conjugate acid of the base. Strong acids ionize completely in water to form hydronium ions and a conjugate base of the acid. There are some examples. And weak acids ionize partially in aqueous solutions to give only hydronium ions. The examples are below. Also, ionization is the ability of an acid to dissolve in the water to produce H plus as the only positive ion together with the negative ions. H plus, that is hydrogen ion. Take note that electrolytes are compounds that conduct electricity, while non-electrolytes do not conduct electricity. Moving on to water. Let's go to the definition of water. Water is a universal solvent by which substances required for existence are dissolved or suspended. Let's go back to the properties of water. Okay, water has a dipole character. Water has an irregular tetrahedron structure. It has a bond angle of 109.5 degrees, making it slightly skewed, and it is also an ideal or universal solvent. Water also exists in the 3 states of matter. Depending on the temperature, it could be solid, could be liquid, could be gaseous. Please note that the law of mass action enables water molecules to be slightly reversed. yielding hydrogen ion and hydroxide ion. We have the question below. Water in a reversible reaction will give you hydrogen plus hydrogen ion. Okay, moving on. The law of mass action states that a chemical reaction like A plus B in a reversible reaction will give you C plus D. We proceed to the right to a new equilibrium position if there is an increase in the concentration of either A or B or both, and if there is an increase in the concentration of C or D or both, it will shift to the left to the new equilibrium position. Ionization is the process of dissociation. Okay, moving on to the ionic product of water. Let's look for the ionic product of water, Kw. Okay, to find the ionic product of water, 1 mole of water equals 18 grams. You can see the calculation below. Then you have to look for the molar concentration of water, which is 1 liter of water is equal to 1000 over 18, which will give you 55.56 mole per liter. Okay, moving on, the probability of hydrogen ion or hydroxide ion in water is 1.8 times 10 raised to the power of minus 9. Please take note that the minus sign is up and the 9 is up. Okay, so let's go over to find the molar concentration of hydrogen ion or hydroxide ion. That is also the pH or the pOH in water. So the molar concentration of hydrogen ion or hydroxide ion in water is equal to 1.8 times 10 raised to the power of minus 9 multiplied by 55.56. That will give you the answer. Okay, we've gotten the molar concentration of water. So let's move over to find the equilibrium constant, that is product over reactant. So from the equation, we have hydrogen ion plus hydroxide give you water. Then K equals product over reactant, that's what you see here. So you're actually going to go with 1 of the 10 raised to the power of minus 7 divided by 55.6. Kw equals equilibrium constant times concentration of water, which is equal to the concentration of hydrogen ion times concentration of hydroxide ion. That will give you 1 times 10 raised to the power of minus 14 mole per liter squared. Kw is equal to concentration of hydrogen ion times concentration of hydroxide ion. Please, that is minus OH minus no AH plus. Okay, note that electrolytes are compounds that conduct electricity and are decomposed in the process. Example, ethanoic acid. Why non-electrolytes do not conduct electricity since they don't ionize? Example is benzene, urea, and so on and so forth. So before you go, here are some questions to test your knowledge. 1. State the law of mass action. 2. Derive the equation for the ionic product of water. 3. Differentiate between the following. 1. Acid and base. 2. Electrolyte and non-electrolyte. 3. Strong acid and conjugate acid of the base. And 4. Weak acid and conjugate base of the acid. Question 4. List 2 physical properties each for acid, base, and water. And the last question, write a chemical equation of water. Okay, thank you all for watching. Please don't forget to subscribe to Coaching Peeps. I'll see you in our next video. Thank you so much. And in our next video, we're going to be talking about how to calculate the pH and pOH.